Hello students, now let's have a look at the data analysis and coding. Analysis of data is a process of inspecting, cleaning, transforming and modeling data with the goal of highlighting useful information, suggesting conclusions and supporting decision making. Coding is a process by which observations recorded in the course of social research, typically in a social survey questionnaire, are transformed from raw data into categories and classification, which then become the subject of quantitative data analysis. Coding involves the act of measurement, for in classifying answers to a question, one is trying to measure the underlying social variable. Looking at the content, we will be looking at the data analysis procedures, processing and data analysis, editing and coding. What is data analysis? Data analysis has multiple facets and approaches encompassing diverse techniques under a variety of names in different business, science and social science domains. The data after collection has to be processed and analyzed in accordance with the outline laid down for the purpose at the time of developing the research plan. This is essential for the scientific study and for ensuring that we have all relevant data for making contemplated comparisons and analysis. By the time you get to the analysis of your data, most of the really difficult work has been done. It's much more difficult to define the research problem, develop and implement a sampling plan, conceptualize, operationalize and test your measures, and also develop a design structure. If you have done this work well, the analysis of the data is usually a fairly straightforward affair. In most social science research, the data analysis involves three major steps. 1. Cleaning and organizing the data for analysis, that is the data preparation. Next, describing the data, that is descriptive statistics. Third, testing hypotheses and models, that is called the inferential statistics. Data preparation involves checking or logging the data in, checking the data for accuracy, entering the data into the computer, transforming the data and developing and documenting a database structure that integrates the various measures. Descriptive statistics are used to describe the basic features of the data in the study. They provide simple summaries about the sample and the measures. Together with simple graphic analysis, they form the basis of virtually every quantitative analysis of data. With descriptive statistics, you are simply describing what the data shows. Inferential statistics investigate questions, models and hypotheses. In many cases, the conclusion from inferential statistics extend beyond the immediate data alone. In most research studies, the analysis sections follows these three phases of analysis. Descriptions of how the data were prepared tend to be brief and to focus on only the more unique aspects of your study, such as specific data transformations that are performed. The descriptive statistics that you actually look at can be voluminous. In most write-ups, these are carefully selected and organized into summary tables and graphs that only show the most relevant or important information. Usually, the researcher links each of the inferential analysis to specific research questions or hypotheses that were raised in the introduction, or notes any models that were tested that emerged as part of the analysis. In most analysis, write-ups is especially critical to not miss the forest for the tree. If you present too much detail, the reader may not be able to follow the central line of the results. Often extensive analysis details are appropriately relegated to appendices, reserving only the most critical analysis summaries for the body of the report itself. What are the data analysis procedures? Once you have selected the topic of research and have gone through the process of literature survey, establish your own focus of research, selected the research paradigm and the methodology, and prepared your own research plan and have collected data, the next step is analysis of the data collected before finally writing the research report. Hence, the use of data analysis, you can convert data into information and knowledge and explore the relationship between variables. Understanding of the data analysis procedures will help you to 1. Appreciate the meaning of the scientific method, hypothesis testing and statistical significance in relation to research question. Next, realize the importance of good research design when investigating research questions. Have knowledge of a range of inferential statistics, their applicability and limitations in the context of your research. You will be able to devise, implement and report accurately a small quantitative research project. Be capable of identifying the data analysis procedures relevant to your research project. Show an understanding of the strengths and limitations of the selected quantitative or qualitative research project. Demonstrate the ability to use word processing, project planning and statistical computer packages in the context of a quantitative research project and report. Be adept of working effectively alone or with others to solve a research question problem quantitatively. The literature survey which you have carried out guides you through the various data analysis methods that have been used in similar studies. Depending upon your research paradigm and methodology and the type of data collection, it also assists you in data analysis. Hence, once you are aware of the fact that which particular procedure is related to your project, you get the answers to what kind of data analysis tools are identified for similar research investigations and what data analysis procedures should you use for your purpose. There are numerous ways under which data analysis procedures are broadly defined. The following diagram makes it evident. There are in fact a number of software packages available that facilitate data analysis. These include statistical packages like SPSS, SAS and Microsoft Excel, etc. Similarly, tools like spreadsheets and word processing software are multi-purpose and very useful for data analysis. Now, coming to the processing and data analysis. It involves a number of closely related operations which are performed with the purpose of summarizing the data collected and organizing these in a manner that they answer the research questions. Technically speaking, processing involves editing, coding, classification and tabulation of collected data so that they are amenable to analysis. The term analysis refers to the computation of certain measures along with searching for patterns of relationships that exist among data groups. Thus, in the process of analysis, relationships or differences supporting or conflicting with original or new hypothesis should be subjected to statistical tests of significance to determine with what validity data can be said to indicate any conclusions. Analysis of data in a general way involves a number of closely related operations which are performed for the purpose of summarizing the collected data and organizing these in such a manner that they answer the research questions. Now, coming to editing, it is a process of examining the collected raw data or information to detect errors and omissions and to correct these when possible. As a matter of fact, editing involves a careful scrutiny of the completed questionnaires or schedules. Editing is done to assure that the data are accurate, consistent with other facts gathered, uniformly entered, as completed as possible and have been well arranged to facilitate coding and tabulation. With regard to points or stages at which editing should be done, one can talk of field editing and central editing. Field editing consists in the review of the reporting forms by the investigator for completing what the latter has written in abbreviated or ineligible form, a fact that individual writing styles often can be difficult for others to decipher. This sort of editing should be done as soon as possible after the interview, preferably on the very day or on the next day. While doing field editing, the investigator must restrain himself and must not correct errors of omission by simply guessing what the informant would have said if the question had been asked. Central editing should take place when all forms or schedules have been completed and returned to the office. This type of editing implies that all forms should get a thorough editing by a single editor in a small study and by a team of editors in case of a large inquiry. Editors may correct the obvious errors such as an entry in the wrong place, entry recorded in months when it should have been recorded in weeks, and the like. In case of inappropriate or missing replies, the editor can sometimes determine the proper answer by reviewing the other information in the schedule. At times, the respondent can be contacted for clarification. The editor must strike out the answer if the same is inappropriate and has no basis for determining the correct answer of the response. Editors must keep in view several points while performing their work. They should be familiar with instructions given to the interviewers and coders as well as with the editing instructions supplied to them for the purpose. Next, while crossing out an original entry for one reason or the another, they should just draw a single line on it so that the same may remain legible. They must make entries on the form in some distinctive color, and that too in a standardized form. And they should initial all answers which they change or supply. Editor's initials and the date of editing should be placed on each completed form or schedule. Data cleaning is an important procedure during which the data are inspected and erroneous data are, if necessary, preferable and possible, corrected. Data cleaning can be done during the stage of data entry. If this is done, it is important that no subjective decisions are made. The guiding principle is, during subsequent manipulations of the data, information should always be cumulatively retrievable. In other words, it should always be possible to undo any data set alterations. Therefore, it is important not to throw information away at any stage in the data cleaning phase. Now, coming to handling of blank responses. Not all respondents answered every item in the questionnaire. Answers may have been left blank because the respondent did not understand the question or did not know the answer, was not willing to answer, or was simply indifferent to the need to respond to the entire questionnaire. If a substantial number of questions, say 25% of the items in the questionnaire have been left unanswered, it may be a good idea to throw out the questionnaire and not include in the data set for analysis. In this event, it is important to mention the number of returned but unused responses due to excessive missing data in the final report submitted to the sponsor of the study. If, however, only 2 or 3 items are left blank in a questionnaire with, say, 30 or more items, we need to decide how these blank answers or responses are to be handled. One way to handle a blank response to an interval scaled item with a midpoint would be to assign the midpoint in the scale as a response to the particular item. An alternative way is to allow the computer to ignore the blank responses when the analyses are done. Coming to coding. Coding means the transformation of data into a form understandable by computer software. Coding is a process for both categorizing qualitative data and for describing the implications and details of these categories. A code is a rule for converting a piece of information, for example, a letter, word, phrase or gesture into another form or representation, not necessarily of the same type. Any combination of codes can be assigned to a specific response. Coding refers to the process of assigning numerals or other symbols to answers so that responses can be put into a limited number of categories or classes. Such classes should be appropriate to the research problem under consideration. They must also possess the characteristic of exhaustiveness and also that of mutual exclusiveness, which means that a specific answer can be placed in one and only one cell in a given category. Another rule to be observed is that of unidimensionality, by which is meant that every class is defined in terms of only one concept. Coding is necessary for efficient analysis, and through it the several replies may be reduced to a small number of classes which contain the critical information required for analysis. Coding decisions usually should be taken at the designing stage of the questionnaire. This makes it possible to pre-code the questionnaire choices, which in turn is helpful for computer tabulation, as one can straightforward keep punch from the original questionnaires. But in case of hand coding, some standard method may be adopted. One such standard method is to code in the margin with a colored pencil. The other method can be to transcribe the data from the questionnaire to the coding sheet. Whatever method is adopted, one should see that coding errors are altogether eliminated or reduced to the minimum level. The classification of information is an important step in preparation of data for computer processing with statistical software. One code should apply to only one category, and category should be comprehensive. There should be clear guidelines for coders, that is the individual who is coding, so that the code is consistent. Some studies will employ multiple coders working independently on the same data. This minimizes the chance of errors from coding and increases the reliability of the data. Initially, one does open coding, considering the data in minute detail while developing some initial categories. Later, one moves to more selective coding, where one systematically codes with respect to a core concept. For quantitative analysis, data is coded usually into measured and recorded as nominal or ordinal variables. Questionnaire data can be pre-coded. It's a process of assigning codes to expected answers on designed questionnaire. Field coded, the process of assigning codes as soon as the data flows, usually during field work. Post coded, coding of open questions on completed questionnaires, or office coded, which is done after field work. Note that some of the above are not mutually exclusive. For disciplines in which a qualitative format is preferential, including ethnography, humanistic geography, or phenomenological psychology, a varied approach to coding can be applied. Two-step process, beginning with basic coding in order to distinguish overall themes, followed by a more in-depth interpretive code in which more specific trends and patterns can be interpreted. Coding is the development and use of a language that will be used to transfer data from the instrument which was employed in data collection process to a code book or directly to the computer in a form that is appropriate for data analysis and reporting results. For the purpose of this course, this means making decisions about how to represent the data you collected on questionnaires in a way that the SPSS program will use effectively to do analysis. Entering data is then done by putting the appropriate number for each datum, that is a singular of data, into an appropriate place in a data file. The first computer assignment requires you to build a data file which contains coded responses from at least 50 of the people who completed your questionnaire. There are some concepts which students need to be very clear before they begin the coding process. These include the difference between variables and values. Variables are logical groupings of attributes. Values are the attributes thus grouped. So, the variable gender has two attributes or values, female and male, the way it is usually constructed in a society. The variable age has many possible values, that is 18, 19, 20, 21, etc. It is important to remember that a variable needs more than one value. If all your respondents are social work major students, then major is not a variable. Don't waste your time coding and entering that data. If you start with an attitude such as the first item on the demonstration questionnaire, my heart goes out to people in wheelchairs, you need to have a code for each of the possible values, that is strongly agree, agree, undecided, disagree, strongly disagree. One way to do this, which I think is easiest way, is to start with 1 and use as many numbers as you need. So, the coding becomes 1 for strongly agree, 2 for agree, 3 for undecided, 4 for disagree, and 5 for strongly disagree. These are entirely arbitrary. You can reverse these or use any numbering scheme you want, but you need to be sure that you remember what the codes mean. A good way to remember is to prepare a code sheet. This is best done by using a blank copy of the questionnaire which you used to collect the data. Variables that have the same values will be coded identically. The next group of items, behavior variables, are all yes or no questions. These can be coded 1 for yes and 2 for no. It is okay for the 1 to be the code for strongly agree for one variable and for one to mean yes for another. Later, we will tell the computer what everything means. It is usually the case that the values for each demographic value will be coded differently, so that the gender has the codes 1 for female and 2 for male. Marital status would be 1 for single, 2 for married, etc. A variable such as age, which is already represented by numbers, uses those numbers as the code. So, for example, the age of 22 is coded as it is, that is 22. Other open-ended responses such as majors are a little more complicated. Often we just code the first response we get as 1, the second as 2, and so on. However, you may want to reserve the low numbers for frequently occurring values. For example, if you have several social work majors in your sample, use 1 for social work, since it is easy to remember. Open-ended items that have more individualistic responses, such as what else do you think about this topic, need to be coded more creatively. Remember, write things down. Keep a record of these codes on your code sheet so that you can remember what they mean. Once you are clear about the coding process, you are ready to begin the data entry. Coding for an open-ended question is more tedious than a closed-ended question. What is your monthly income? Here the respondent would indicate his monthly income, which may be entered in the relevant column. The same question may also be asked like this: what is your monthly income? We may code the class less than rupees 5,000 is 1, rupees 5,000 to 8,999 as 2, rupees 9,000 to 12,999 as 3, and rupees 13,000 and above as 4. Coding of open-ended questions is a more complex task, as the verbatim responses of the respondents are recorded by the interviewer. In what categories should these responses be put to? The researcher may select at random 60 to 70 of the responses to the question and list them. After examining the list, a decision is taken to what categories are appropriate to summarize the data and the coding scheme for categorized data as discussed. A word of caution that while classifying the data into various categories, we should keep provision for any other to include responses which may not fall into our designated categories. It may be kept in mind that the response categories must be mutually exclusive and collectively exhaustive. We give below a part of the questionnaire and discuss the coding scheme for the same. Please note that the objective here is not to evaluate the questionnaire, but to design a coding scheme for any given questionnaire to study. Look at the questionnaire given in exhibit. Let's design the coding scheme for the questionnaire given in the exhibit. Number 1. We note that the question number 1 may have multiple responses because a respondent could read more than one newspaper. There are 5 alternatives assigned for question number 1. Therefore, we will use 5 columns in the data matrix to record the responses of this question. If a respondent reads Times of India, we code it a value 1, otherwise 0. Similarly, it is done for the remaining newspapers. However, if there is a respondent who reads Times of India and Indian Express, we will code questions 1A and 1C having a value of 1, and for the remaining parts, namely B, D and C, the coded value would be 0. For question number 2, the respondent can choose only one of the 4 alternatives. Therefore, one single column is required to record the responses of the respondent. The response categories are mutually exclusive and collectively exhaustive. Whichever category is chosen by the respondent, that is coded 1, and the remaining are coded 0. Question number 3 has 7 parts, and the respondent is to rate each one of them on a 5-point scale ranging from 1 to 5. Therefore, a total of 7 columns is required to record the responses of the respondent. There are 6 features of Times of India mentioned in question number 5 and labeled as 5A to 5F. The respondent is to rank them from 1 to 6 with regards to the importance it gives to each of these features. Therefore, we need 6 columns for this. Suppose the rating is 2, 3, 6, 1, 4 and 5 for questions numbering 5A to 5F respectively. The same numbers would appear on the coding sheet corresponding to this question. Question number 6 is divided into 5 parts. For each of the part, one separate column is required. 6A indicates the age of the respondent, which will be indicated as per the data revealed by the respondent. Question 6B is concerning the sex of the respondent. Here male respondents are coded as 1, whereas female respondents are coded as 0. Question 6C indicates the total number of members in the household. Question 6D is concerned with the occupation of the respondent. Question 6E mentions the monthly income of the household put in categorized form. Here the responses are mutually exclusive and collectively exhaustive. If the respondent has a monthly income of less than 5,000 rupees, the response is coded as 1. If monthly income is between 5,000 and 10,000 rupees, it is coded as 2. In case it is between 10,001 and 15,000, the code is 3, and so on. The above discussion can be shown below in the form of a code book. The data matrix corresponding to the above coding scheme, the respondent number 1 reads both Times of India and Indian Express and no other newspaper. This is indicated by code 1 corresponding to question 1A, and for the remaining parts of the question, 0 is indicated. Question number 2 indicates that the respondent is reading Times of India from 6 to 12 months. The rating of various features of a newspaper in terms of the interest he has in them is indicated by responses indicated in questions 3A to 3G. The respondent is not very interested in critical news. interested in international news, not particular about city news, very interested in corporate and business news, very uninterested in sports news, and interested in people and lifestyle news, and leisure, art and entertainment news. The respondent rates Times of India on 5 attributes. He can give a possible rating Times of India on various attributes on a scale of 1 to 5, where 1 is on an extremely unfavorable side, whereas 5 represents extremely favorable side. He has rated Times of India on news content as 4, editorial as 3, weekend supplements as 5, weekdays supplement as 3, and layout as 5. The respondent is of 32 years of age and is a male as indicated by code of 1 to question 6b. There are 4 members in his household. His occupation is business and has a monthly income between Rs 10,000 to 15,000 as indicated by code 3 for question 6c. Respondent 2 does not read Times of India. In fact, the respondent is a reader of Hindustan Times and no other newspaper, and therefore the questions mentioned in questions numbering 6 are asked to the respondent. The respondent is 30 years of age and a female as indicated by code 0 for question 6b. The respondent has 3 family members, is a professional and have monthly income between 15,000 to 20,000 rupees as indicated by code 4 corresponding to 6c.